Number 42. A 50-foot ladder is leaning against a building. If the base of the ladder is being pulled away from the building at a rate of 4 feet per second, then the top of the ladder will move down the wall at a rate of blank feet per second. At the moment, the base of the ladder is 14 feet from the base of the building. So if I just draw this real quick, this is always a good place to start, by the way. If you're unsure about a problem or haven't seen one like it before, just draw a picture. Most of the time, it will help a lot. Alright, so this isn't a very straight line. I struggle drawing straight lines. Anyway, so the ladder is 50 feet long, and it tells us, well, it's going to be some height above the ground and then some distance from the wall. And so we're actually going to set up a related rate here. And I'll show you what that means if you're unfamiliar with that. So anyway, the equation of this triangle, this is a right triangle. The equation of this right triangle, no matter what point in time you are, it's going to be a squared plus b squared equals 50 squared. So now I'm going to take the time derivative of both the left and right hand side. So derivative of a squared with respect to time would be 2a, and then always remember to multiply by your dA dt. Because you're taking the time derivative, but it's not of time, and so you have to add this little factor, or multiply by this little factor out front. And then the derivative of b squared is very similar, so it's plus 2b times dB over dt. And then the derivative of the constant is always just going to be 0. So next thing I'm going to do, just for simplicity's sake, I'm just going to divide all the things by 2. Just so in the end you end up with a dA dt plus b dB dt equals 0. So now we just have to find values to put in here. And well, what are we looking for first of all? We should probably check back on that. The top of the ladder will move down the wall at a rate of blank feet per second. So this is A, right? And A is the distance from the top to the bottom. And so we're looking, in the end, we're looking for what is dA dt. So I bet we can find these other three things and then just solve for it. Well, can we solve for A? Let's see. Well, we don't know how tall it is, so let's just leave that alone for now. We do know how far away from the wall it is at this point. It says it's 14 feet away. So 14, and then do we know how quickly it's moving away from the wall? Do we know dB dt? Well, it's being pulled away from the building at a rate of 4 feet per second. So yes, we do know that. That's just going to be 4. Right, so I bet we can find this A somehow. Well, if B is 14, right, and our hypotenuse is 50, then we can just use the Pythagorean theorem to solve for A, right? A squared plus 14 squared equals 50 squared, right? And so A is going to be 48 feet. So we can plug that in here, 48, and then times dA dt, and then solve for dA dt. So 14 times 4, that's 56. Once I subtracted it over to the right side, that'll be negative 56. Divided by 48, and that simplifies to divide top and bottom by, let's see, so that's negative 28 over 24. Okay, so divide top and bottom by 4. So that'll be negative 7 over 6, which means that the length of A is decreasing, which makes sense. Like if this is falling, then obviously the distance from here to the bottom is going to be decreasing, and therefore the rate's a negative number. But we don't see any negative numbers here, and that's just because it says it's moving down the wall at this rate. So we can still use this just without the negative, and we get 7/6 feet per second. Alright, so if you have any questions from other tests, make sure to leave a comment, and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe, and I'll see you next time.